Hello my dear students, I warmly welcome you to CR Digital Classes. So now in this lecture, we are starting with another unit, that is the last unit in our syllabus, unit 4. Okay, so in the previous lecture we discussed the problems in different methods of linear differential equation of constant coefficient sum. So now with this lecture we are going to start that unit 4. So the name of unit 4 is given by higher order linear differential equations and partial differential equations. Okay, so we have two parts: higher order linear differential equation. This is the continuation of unit 3. Continuation of unit 3 amma. Name of unit 3 is also higher order linear differential equations only. Okay, continuation of unit 3, and where we discussed that method of undetermined coefficients. Method of undetermined coefficients. Now here continuation is method of variation of parameters. In unit 3 we discussed the method of undetermined coefficients. Its continuation method is method of variation of parameters. So continuation of unit 3 of name is higher order linear differential equation. Rest of the topic is partial differential equations. Okay, so in higher order linear differential equations, we have 5 topics in unit 4. So the first topic is a method of variation of parameters. Second method is a linear differential equation with non-constant coefficients. In unit 3 we discussed total linear differential equation with constant coefficients now. So here we are going to discussing non-constant coefficients. You will get a non-constant coefficients like x square, x in that format. Okay, all variables. Third, the Cauchy-Euler equation, very important topic from this unit. Okay, very important. The Cauchy-Euler equation. Next important topic is Legendre's linear equation. Okay, especially for the derivation purpose, this Legendre equation is very important. Next, fifth topic is miscellaneous differential equations. Okay, that is the fifth topic. So these 5 methods are in higher order linear differential equation. Next, in partial differential equation, continuation method is formation and solution of the partial differential equation. Next, equations easily integrable. Equations easily integrable. And last topic of this unit is linear equations of first order. In ordinary differential equation, we discuss a linear differential equation. So the same thing we are also going to discussing linear equations in partial differential equation, that too first order. Okay, so these 8 topics, from 8 topics among. So this 8th topic is very important. You will get one essay question from this topic, and from the Cauchy-Euler equation or Legendre's linear equation. From these 2 topics you will get one essay questions. From the remaining topics you will get variation of parameter method is also very important. So from these 4 methods you will get at least 2 essay questions, and from the remaining topics you will get short questions. From this chapter you can expect the derivation also. Derive the Cauchy-Euler equation or explain about Legendre's equation. So the present lecture we are going to discussing actually in order wise it is the fourth subtopic in order wise. So the present lecture is fourth subtopic from this unit, but we are discussing now only. The main reason is this question, whatever we discuss now, write the solution of the nth order Legendre equation, asked recently in the June-July paper of 2023. In the last year, in June-July 2023 paper, they asked the question based on this Legendre's linear equation. Explain about Legendre's linear equation. So unexpected question. Explain about Legendre's linear equation. Whenever you see that question paper which is existing in that format, explain about Legendre's linear equation. So majority of the student will not touch that problem. But when you listen my class, that explanation is solution is very easy. So that's why always I used to say that from the 4th unit you can expect the theory format questions also. The first method is Legendre's linear equation. You can also see the question, write the solution of the nth order Legendre's equation, or else they will also ask the question, explain about Legendre linear equation. Okay, so very important problem. In the next lecture we are going to discussing problem based on this method only. And before that we are going to discussing Cauchy-Euler equation. For that method also we are going to discussing the general derivation and problem based on that method. Okay, just remember carefully and follow my words, Amma. So we are entering into the general derivation of the nth order Legendre equation. First of all, what is that nth order Legendre equation we are going to discussing, Amma? An equation of the form k suffix n ax plus b whole power n into d power n into y by dx power n plus k suffix n minus 1 into ax plus b whole power n minus 1 into d power n minus 1 into y by dx power n minus 1. If you proceed in that format, plus up to so on k suffix 0 into y is equal to q of x. Equation number 1 is called Legendre's linear equation. Observe carefully, here you have that order is n, that d power ny by dx power n, it is order. Okay, order of this equation number 1 is small n. Degree is 1. Degree is 1. So therefore that's why we are calling it as a Legendre's linear equation. Okay, where k suffix 0, k suffix 1 up to so on k suffix n are called constants, and that RHS is a function in the given function variable. Okay, so clear? Whenever you have a differential equation in this format, so the differential equation is called Legendre's linear differential equation. Legendre's linear equation. So therefore now, so how we can solve this equation? Okay, so that is we are going to discussing now. Equation number 1 can be reduced to linear equations with constant coefficients. Okay, so directly we cannot solve this problem, Amma. By applying some suitable function, that is method of substitution, you have to convert this equation number 1, whatever you have this equation number 1, okay, maximum they will give second order, Amma. They will not give that nth order Legendre's equation. They will give second order Legendre equation. That second order Legendre equation, by substituting the suitable function in the given ax plus b format, Amma. So by substituting the given suitable function, we have to reduce the given equation into linear equation with constant coefficients. You know very well that unit 2 regarding that problems only. By the substitution, ax plus b is equal to e power z. Okay, for this method we are going to use the method of substitution. For the next, before this one, so we are going to discussing one more method, Cauchy-Euler problem, where also we are going to write x is equal to e power t. The substitution value in that problem is x is equal to e power t. For this problem, ax plus is equal to e power z. Just remember these two functions. Don't get confusion between that Cauchy-Euler and Legendre's. So therefore, if you take that substitution function as ax plus b, okay, so therefore let ax plus b is equal to e power z, taking it as equation number 2. After taking that function, Amma, apply that logarithm on both sides. Okay, observe the procedure carefully. Logarithm of ax plus b is equal to log of e power z. On both sides we are applying that logarithm. So logarithm of ax plus b. So if you send this z value, so z into log e base e. You know very well log e base e value 1, Amma. So it is 1. So therefore z into 1, again you will get z only. So therefore we are writing that value log of ax plus b is equal to z. Just remember that value also, log of ax plus b is equal to z. Now from equation number 2, that is ax plus b is equal to e power z, ax plus b is equal to e power z, differentiating on both sides, Amma. So then you will get, if you differentiate with respect to z on both sides, differentiation of ax, Amma, a into constant a into x differentiation, it will become a is a only, x differentiation with respect to z is dx by dz, plus b value 0, it is equal to in RHS e power z, differentiation with respect to z. So therefore a into dx is equal to, if you send the dz value to RHS, it will become e power z into dz. So that's why we are writing directly a into dx is equal to e power z into dz. Clear? So now after getting that term, Amma, so send this dx value to RHS and send this e power z value to LHS dz by dx is equal to a by e power z. Dz by dx is equal to a by e power z. So therefore dz by dx is equal to a by, in place of e power z so you can substitute equation number 2 value ax plus b. Okay, so therefore taking it as equation number 3. Now observe carefully in equation number 1 in equation number 1 now our final motto is we are going to deriving the values of these coefficients so ఇక్కడ మీ coefficients ఉన్నాయి కదా సో ఈ coefficients values ని derive చేయాలి, that means including with the d power n y by dxn also. Okay, but to derive those values first of all we are starting with that first order differential term dy by dx. Okay, so then dy by dx how you can write so dz by dx into dy by dz. Again dz if you make cancel, then again you will get dy by dx only in RHS. So therefore without loss of generality we can write that function dy by dx is equal to dz by dx into dy by dz. So therefore dy by dx is equal to a by ax plus b. So dz by dx value from equation number 3 a by ax plus b, and dy by dz value we are writing as it is dy by dz. So therefore ax plus b into, so send this ax plus b value LHS then you can obtain that ax plus b into b dy by dx. I will rub that some terms here so to avoid your confusion. So now you can see here, send this ax plus b value to LHS, then ax plus b into dy by dx is equal to a into dy by dz. Okay, so therefore ax plus b dy by dx is equal to a into, you know very well, d by dz. D by dz is equal to d, okay, d dash, differential operator. In that Cauchy-Euler general derivation also we are going to denoting d by dt. D by dt is equal to capital D or d1 in that format. So here d by dz is equal to d dash, whatever it is, a differential operator where d dash is equal to d by dz is a differential operator. So we are taking that value as equation number 4. That means while solving problem based on this Legendre's linear equation, whenever you see this word ax plus b dy by dx, directly you have to write down a into d dash y, where a you will get from the ax function. You can get that small a value. So అది ఎంత ఉంటుంది రాయాలి అక్కడ. Similarly next if you apply that if you differentiate this equation number 4, if you again differentiate equation number 4 then and apply that procedure you will get this value. Okay, so therefore ax plus b whole square d square y by dx square is equal to a square into d dash into d dash minus 1 into y. Why? Because if you apply that second derivative ax plus b whole square d square y by dx square, you will get a term in this format, a square into d square y by dz square minus a square into dz dy by dz. In this format you will get. Okay, so you know very well a square into d square y by dz square you can write d dash, okay, d dash square minus a square into dy by dz you can write d dash. So therefore from that condition simply we can write so if by taking that value so therefore if you take a square common, d1 square minus d dash. Okay, so therefore a square into, again if you take d dash common, d dash minus 1, d dash minus 1. So in this format you will get y anamata. So here y will come, so here y will come, here y will come. So in this format you will get the values. Take that equation number 5. Okay, second term, second derivative term. Similarly if you proceed in that format you will get the third term, but remember coefficient is always exist in ax plus b format. If you apply the second derivative for that ax plus b you will get square. If you apply the third derivative for that equation number 5, okay, so you will get ax plus b whole cube d cube y by dx cube. So therefore a cube into d dash into d dash minus 1 d dash minus 2 into y. Ante so that is a continuation process. First you will get a d dash, for d by dz you will get For d by dz, you will get to d dash. For d square by dz square term, you will get to d dash into d dash minus 1. For d cube by dz cube, d cube by dz cube, you will get to d dash into d dash minus 1, d dash minus 2. Okay, if you get to d power 4 by dz power 4, you will get to d dash minus 1, d dash minus 2, d dash minus 3. So in that format. So these values you have to substitute while solving problems based on the Legendre's linear equation. Okay. So to know the reason behind writing these values, so I explained this total derivative. While solving problem summa, in that problem they will write directly these values. Student will get confusion from where you will get those values. So from here we are getting those values. Okay. So the same derivation you have Cauchy-Euler equation also, where the notation will be changed. So therefore substituting equation number 4, equation number 5 and equation number 6 in equation number 1. So to obtain a linear differential equation with constant coefficients. Okay, so after substituting that 4, 5, 6 in equation number 1, we can obtain a linear differential equation with constant coefficient. What is that form, Amma? F of d dash of y is equal to q of x. Okay, it is the form of that linear differential equation with constant coefficient. After getting this equation, Amma, what is the equation for general solution? Y is equal to y suffix c plus y suffix p. You know very well how to calculate that complementary function and particular integral. Depending upon the f of d dash value, we can calculate y suffix c value. Depending on the q of x value, we can calculate y suffix p value. By adding them, we can get the general solution for the given Legendre's linear equation. Okay, you have to remember these symbolic notations. D by dz is equal to d dash, d square by dz square is equal to d dash into d dash minus 1. Again, don't write this total explanation in the problem. So wherever you see that d square y by dz square, just simply write to d dash into d dash minus 1. Clear? So this is the total explanation of this problem. So recently, in the last year 2023 question paper, this question came, Amma. So explain about Legendre linear equation. Okay, so be careful while preparing for the final examination. Along with problem Amma, you have to prepare for the theoretic format also. You should be ready to face any kind of question paper. Why? Because you are going to write this exam at once only. Okay, at the first time only that question paper, however it is tough, that is easy. For the next time, okay, if you get failed, Amma, so whatever in the next time, however it is easy, so that little bit tough only. Why? Because lack of preparation, you will not get that interest again. Okay, so therefore, so in the first attempt only, try to clear your subject. Okay, so my videos will helpful to you get that good marks, Amma, not only pass marks, you will get that full marks if you prepare, if you follow all these videos. Okay, this is the total explanation of this introduction topic and Legendre's linear equation. I hope you understood this lecture very well. In the next lecture, we are starting with the first method, variation of parameter of unit 4. So continuation we are going to discussing. Make a perfect practice, prepare well. Until bye. Thank you.